Okay, so in this recap, we're going to look at how to write formula from the name of the compound. So I've put a four-step method here to show you in green. And first, to find out the formula or to write the formula, you need to find the formula of the cation first. And note all sorts are made up from anion and from your anion, and then your cation, sorry, and then your anion, which is your negative ion. So your cation, you're positive, and your anion, you're negative. Now, first we need to find the formula of the cation. Now, with the formulas, you either need to look in the periodic table, or if it's a molecular ion, you need to know it out of your head. This is a molecular ion, so I know that this is NH4 plus. That's the formula of the cation. Then you need to find out the formula of the anion. And that's carbonate, that's a molecular ion. You can't look in the periodic table for that. It's CO3, 2 minus. Now you need to know that out of your head. And then you can find the valency or the charge, and then cross the valencies or charge to find out the multiples, the ratios that these two ions interact with each other. So you've got 1 here and then 2 here. So that means that if we cross the charges or the valency, so the valency here is 1, the valency here is 2, because the charge is 1 on the ammonium and the charge is 2 on the carbonate. So if you cross those valencies, that just tells us how many of the other ion we're going to have. So your carbonate ion, we have no, your ammonium ion, sorry, we have 2 of your ammonium ions, so NH4. Then we've got to put that into brackets because it's a molecular ion, and to show that we've got 2 of the whole of that ion, not just 42 of the hydrogens if it was without the brackets. And then your carbonate is CO3. We've only got 1 of those, so that's your formula there. And we're gonna look at now we're gonna break these down step by step. So first, just looking at how we can find out what the charge is, or what the chemical formula of the ion is, and we can look at the periodic table. Your metals are on your left-hand side, and then your non-metals are on your right-hand side, and they're separated by this stepped ladder here, which goes down to the left of boron, and then just steps down like this. Now, to find out the charge on any ion or the valency, so you just look at the group number it's in. So if it's lithium, if it's in group 1, all of these ions, or all group 1 ions form a positive charge because they like to lose 1 electron. All group 2 ions or elements like to lose 2 electrons and therefore become a 2 plus charge. Your transition metals, however, you can't just work those out. You have to kind of you have to look at the Roman numerals there. So let's go for iron 2. So for iron 2, the Roman numerals will tell us what the charge is. So you can have iron 2 or iron 3, and those are common ones that you'll come across, and that will just tell us the charge. So here we've got a 2 plus charge, here we've got a 3 plus charge. Remember, metals are always positive, and that's just shown in the table there. Then your non-metals on the other side of the step ladder, they form negative. So your group 7 here, they form a negative charge. Your group 6, they form 2 negatives because they like to gain 2 electrons. Your group 7 like to gain 1 electron, therefore they have an overall charge of a negative 1. And then your group 5, they like to lose 3 electrons. Okay, so you can look at the periodic table here to find out what charge there are. So if you had phosphorus, for instance, phosphorus would be P3 minus. It likes to lose 3 electrons. Okay, so that's how you find out the charge for atomic ions. Now, to find out the charge for molecular ions, you actually can't do that by looking at the periodic table. So you just have to remember it. There's nothing more you can do. So note something I didn't mention before, actually. The charge is equal to the valency, and the valency just tells us the number of bonds that it can form. So here in your molecular ions, you need to know all of these. A hydroxide is OH minus, and your sulfate is SO4 2 minus. nitrate is NO3 minus, carbonate is CO3 2 minus, and ammonium is NH4 plus. So if I was to write down the valency of each of these, I mean, you can see the charge, and I've said that the charge here is equal to the valency. The valency for your hydroxide is going to be 1, sulfate is going to be 2 because it's a 2 minus, nitrate is a 1 minus, so it's going to be 1, carbonate is a 2 minus, so it's going to be 2, ammonium is a plus 1, so it's going to be 1. And that just tells us how many bonds it can form. Now these, most of these are negative charges actually. So if we had, let's say we had iron, let's say if we had iron 3, so iron 3 plus, we had the cation iron 3 plus, and then we had the anion hydroxide OH minus. Now here again, you can just work out the valencies, then cross the valency. So the valency here is 3, valency here is 1. You can cross the valency to tell us how many of each ions you have. So you're going to have 1 ion, then you're going to have 3 OH minuses. Okay, and notice you don't include the charges in the compound, so don't include charges. Okay, so don't include charges, and no charges there. Okay, in the final formula. Oh. Okay, now this is I've just summarized these in the table, and just to show you what you need to remember. So for your atoms, your positive atoms, you know what the formula is by looking at the periodic table. You can find out the chemical symbol, and you can find out the charge depending on what group it's in. So potassium, all group 1 elements, they have a valency of 1. All group 2 elements have a valency of 2. All group 3 elements have a valency of 3. These are some other ones here, which will give you Roman numerals. So you'll have Roman numerals here, 2 or 3 or something like that, to tell you 1, 2 or 3. Okay, to tell you 1, 2 or 3. Then your molecular ions for your positive cations. Now you need to remember these. Ammonium is the only one that you need to remember there for the cations, for the molecular cations, and that's NH4 plus. Your negative ions, however, you need to know that group 7 always form -1, so they have a valency of 1. Group 6 always have a valency of 2, and that's because it's 8 minus the group number it's in, and you get the number there. So it likes to gain 2 electrons to form a 2 minus ion, and therefore it has a valency of 2 because the charge is 2. Group 5 is, because they're in group 5, they like to gain 3 electrons. Therefore, they have a charge of 3 minus, when they do that. Therefore, the valency is 3. But the molecular ions you need to know are here. And again, we've already done this. We've got valency of 1, valency of 1, valency of 2, valency of 2. Okay. So you can see here that all of these have a valency of 2. Okay. So let's look at how we can write these, or how we can do these. So ammonium carbonate, if we put NH4 plus, we need to remember that because it's like the periodic table. Carbonate, again, we need to remember that it's 1 of the golden 5. It's 2 minus. Then we can write out the valency. It's 1 here, 2 here. Then we can cross the valencies. Cross the valencies. We have N. Oh, if we cross the valencies, we'll have NH4. There'll be 2 of those, and there'll be 1 carbonate. Now you don't need to put a bracket over carbonate because there's only 1 of them. If you've got multiple, you do. Iron 3, you've got Fe3 plus. The nitrate, and the Roman numerals tells us that it's 3 plus. The nitrate is minus. Again, you've got your valencies is 3 and 1. If you cross them, then it tells you how many of the other ion you have. So you're gonna have 1 ion here, 1 iron 3, and you have 3 nitrates. Okay, so you've got to put nitrates in brackets because there's 3 of them. Okay, and you don't include the charges. And then aluminium oxide, aluminium's in group 3, so therefore it's going to have a valency of 3. Your oxide, because it's a metal, it's always plus. Your oxygen is O2 minus because it's in group 6, it's a non-metal. You've got your valency of 3, valency of 2, cross them. You're going to have 2 aluminiums and then 3 oxygens. So you're going to have 2 aluminiums, then 3 oxygens. Okay, perfect. Okay, so try to work out these just using the same method that we've done before. Maybe I'll do one, maybe one, and then you can go for it. So your iron 3, let's do iron 3. So we have Fe, we look in the periodic table first, Fe, and we know it's going to be, 3 plus, because it's got a 3 there. So we know it's going to be 3 plus. Oh, hydroxide, OH minus, we know that. So it's going to have a valency of 3 and 1. If we cross those, we don't include the charges. We're going to have 1 iron, and we're going to have 3 hydroxides. OH. We're going to put that, because it's a molecular ion, we put it in brackets and we put it on the outside below. Okay, so try that for the other ones. Give yourself about 5 minutes and then check the answers after. You may want to pause now. Okay, so these are your answers. Just correct them, please. If you need any more practice or anything like that, please do ask your teacher for some more practice. But it's important that you know this before moving on, because it helps you with writing out formulas for salts.